Let's find the general solution to the fourth derivative of y minus y triple prime minus 3y double prime plus 5y prime minus 2y equals 0. So the auxiliary equation in this case is given by r to the power 4 minus r cubed minus 3r squared plus 5r minus 2 equals 0. Again, this is not something that easily solves, but we can do the trial and error method and plug in some values. Especially if you have like the TI-83 or TI-84 calculator, you can put this in Y1 and you can use the table function to plug in some values to easily see whether or not these values solve the auxiliary equation. But R1 and R equals 1 and R equals -2 are solutions. You should verify that. So if that is, if those two are solutions, that means we can write our differential equation or our auxiliary equation, excuse me, as r minus 1 times r plus 2 times, and then what's left of the auxiliary equation is r squared minus 2r plus 1. So the way that you go from here to here is by using auxiliary or by using long division twice. So let me just write that here. So from here to here, we use long division twice. So first you use long division to factor out r minus 1, and then you use r plus 2, or you use long division to factor out r plus 2. And then this is your auxiliary equation. So now the last part of the auxiliary equation is now a quadratic that we can try by factoring. And what we see here is that this is r minus 1 times r minus 1. And so our complete auxiliary equation in factored form is r minus 1 times r plus 2 times r minus 1 times r minus 1. And of course, that can be simplified to r minus 1 cubed times r plus 2 equals 0. And so now r minus 1 cubed equals 0, or r plus 2 equals 0. And so that gives us r equals -2. And we can basically take the cube root on both sides, and then we get r minus 1 equals 0, and then r equals 1. But the important part there is that this has multiplicity 3. We have r equals 1 as multiplicity 3 that comes from this power right here. So let's take a look at what the solutions look like. So r equals -2. We know that the solution, the general solution part that corresponds with r equals -2 looks as follows: e to the power -2x. Okay, so that is part of our general solution. And then here, we start off with e to the power 1x because r equals 1. And then the next solutions, we need 3 solutions because we have multiplicity 3. So we have another e to the power x, and we have another e to the power x. But to get linearly independent solutions, we're going to multiply by x and then by x squared. If we had multiplicity 5, we would add an x cubed and an x to the power 4. So you always go up to the power of x that's 1 less than the multiplicity. So we have our 3 solutions here. And so that means that our final answer for the general solution is y of x equals c1 e to the power x plus c2 e to the power x, and I'm forgetting my extra factor of x there. So it's c2 x e to the power x plus c3 x squared e to the power x, and then plus c4 times e to the power negative 2x. And a quick sanity check to see did we get all of them is to look at the order of the differential equation. We have order 4, and we have 4 coefficients here. Okay, let's take a look at another example. In fact, before we do that, let me remind you of the relationship we saw between operator notation and the auxiliary equation, because if we look at this differential equation, one thing to note here is that note if we write the fourth derivative of y minus y triple prime minus 3y double prime plus 5y prime minus 2y equals 0. In operator notation, we get d to the power 4 minus d cubed minus 3d squared plus 5d minus 2 acting on y equals 0. But if you compare that with the auxiliary equation, r to the power 4 minus r cubed minus 3r squared plus 5r minus 2, and that equals 0, you see that we can go directly from operator notation to the auxiliary equation. We don't necessarily have to rewrite this in the regular form and then go to the auxiliary equation, because it's to go from the operator notation, you just replace every d by an r. So if we look at the following example where we have to find the general solution to the quantity d squared minus 4d plus 5 squared acting on y equals 0, we can directly go to the auxiliary equation. And the auxiliary equation is then given by r squared minus 4r plus 5 in between parentheses squared equals 0. Now, we can write that out. It's not necessary, but we can write that out as r squared minus 4r plus 5 times r squared minus 4r plus 5. And then we see that we have to solve r squared minus 4r plus 5 equals 0, or r squared minus 4r plus 5 equals 0. Now, that's double work, of course. We're not going to solve the same do work twice. So we solve this once, and then whatever we get from that will have multiplicity 2. So the two solutions here each have multiplicity 2. So if you use the quadratic formula, you can show that r equals 2 plus or minus I. So r equals plus or minus 2i. So that's the quadratic formula. And double check that work for yourself. But because it shows up twice, or because we have the power there, both of these have multiplicity 2. So these roots have multiplicity 2. Now, what does that mean for the general solution? So if we look at 2 plus or minus I, we see that alpha equals 2 and beta equals 1. So the solutions that come from this are e to the power 2x cosine x, and then e to the power 2x sine of x, right? The 2 goes in front of the x here in the power of e, and the 1 goes inside the trigonometric function. So, but because these roots both have multiplicity 2, we have to repeat these basic parts, but now we have to put a power of x in front of them. So we have x e to the power 2x cosine x and x e to the power 2x sine x. So these are the ingredients for our general solution. And the general solution then looks as follows. Y of x equals c1 e to the power 2x cosine x plus c2 e to the power 2x sine of x plus c3 x e to the power 2x cosine x, and then plus c4 x e to the power 2x sine of x. And let's double check that we have found all the parts of the general solution. D squared by itself would be second order, and so that would only need 2 coefficients. But notice that we square it here, and so if you would actually FOIL that out, multiply that out, you see that this is actually something that will be d to the power 4 plus a bunch of lower order powers of d. So that's, this differential equation is order, that's order 4. And so we need 4 coefficients that we found here.